But what about liquid hydrogen? The end goal, we see a nice render here of the latest, zero-E concept. And if we look at both research and development platforms, startups, and the OEMs, we see a lot of things are going on in the market nowadays. And this list is still limited because there are more initiatives than these. But what is nice is that at least if we consider research and development platforms at our airport, there are some research and development platforms present, which eventually leads to the fact that we as an airport are more proactive on installing the right and the needed hydrogen or liquid hydrogen infrastructure to support these research and development programs. If we look at the infrastructure at airports, and we already have learned a lot from installing a small liquid hydrogen storage facility at our operational airport, but we eventually would see that a lot of more complex infrastructure is either needed outside the airport terrain or on the airside terrain. Next month, a new research article on-site hydrogen liquefaction, so basically hydrogen liquefaction on an airport terrain, will be published by the Journal of Airport Management, which will present a blueprint for airport master planners on how to deal with potential liquid hydrogen infrastructure on their airport terrain in the future. Next to that, a few months later, a multi-airport case study, which involves the reply of 35 European airports and 50 global airports on the feasibility assessment of on-site hydrogen liquefaction, will be published as well in the same journal. If we look at still the hydrogen molecule, but then in a liquid form at Rotterdam De Hague Airport, we're lucky to have one of the 3 liquefaction plants in Europe around the corner. Air Products has one in Rotterdam, Linde in Germany, and Air Liquide in the north of France. So a 20-kilometer drive will bring liquid hydrogen via trailer to our airport, our liquid hydrogen storage facility, which is located at one of the flight schools at the airport. This liquid hydrogen storage facility will be able to store, in this case, 125 liters of liquid hydrogen, but there's room for expansion as we can change the door into either a 250 or 500 liter storage vessel, which would then be applicable for one of the end users, seen here on the right, which is dependent, of course, of their test plans and the tank size. We will start by dispensing liquid hydrogen to the Hydra 2 drone of the NLR, and then we'll slowly evolve to a aircraft also owned by NLR, the Pipistrel Velis Electro, which is already a battery electric aircraft, which will have a fuel cell on the belly of the aircraft and a liquid hydrogen tank on board next to the pilot, and the fuel cells in this case act as a range extender. With Aero Delft, we will conduct the gaseous hydrogen taxi tests in May, but later on they can make use of this liquid hydrogen storage facility at the airport as well. And what we see with their 2 tanks, one by CryoWorld and one composite 70-liter tank by Fabrum, is that if we have the 125-liter liquid hydrogen storage tank and the Aero Delft 70-liter onboard tank, that with cooling and actually filling, our on-site tank is immediately empty. So therefore we would like to remain flexible and therefore have the luxury to switch from 125 to 250 and 500 liters on site.